Hi everyone. So the first thing we're talking about today is something called logarithms, and that's another big fancy math word that sounds a lot more complicated than it really is. Um, Here's where logarithms came from. Logarithms came from the fact that mathematicians were bothered by equations like this one. Okay. They didn't have a process for solving for this x up in the exponent. And you've seen problems like that. In the last chapter, the last stuff we just did, you had problems where you would write an exponential model. You would write, I don't know, maybe 100 times 1.04 to the power of x. And the problem would say, in what year will the population reach blah, blah, blah. Well, anytime you were looking for the year or the time, anytime you were trying to figure out what this x was equal to, we had to just type it into a calculator and approximate. We had to just look at the table and get as close as we could. We need a way to solve for this x, okay? And so what logarithms are designed for is to bring that x down into the main problem so that you can solve for them, okay? So let's take a minute and basically write down what I just said. So first off, what is a logarithm? A logarithm is just a rearranged form of an exponential equation. It's just a way of taking the pieces of an exponential equation, which are what we worked on in the whole last chapter, and rearranging them, putting them in a different form. So why do we do that? Why do we bother? Well, like I said a minute ago, the reason logarithms came about is to allow us to solve for a missing exponent. Okay, to let us solve for x. So I'll pause for a minute, make sure you get those two things written down. So this here, it is what a logarithm looks like. Notice it's abbreviated log. It has a number here, a number here, and a number here. Well, this number is called the base. Okay, it's the base of the logarithm. That's also equivalent to the base in an exponential form. So that's going to be the thing that you're raising to a power. Okay? And the answer to a log, so on the other side of the equals, what a log is equal to is always an exponent. So this is the base. This is the exponent. So over here, this would be b to the power of x. And then it's always equal to this number, equals a. So this is how we would write something in logarithmic form. This is how we would write something in exponential form. It's always just a rearrangement of a placement of the letters or the numbers, because those will eventually become numbers. So b to the power of x equals a. Or if you're going the other way, log base b of a is equal to x. A log is always equal to an exponent. In fact, you may want to jot that down. A log is really just an exponent in disguise. Okay, so what I'm going to do is I'm going to pick just a couple from down below here to work through with you. I'd like you to write them down. I'll do like one from each section, and then the rest of it is yours to do. It should go really quickly for you. So take a look maybe at this first one. Log base 6 of 36 equals 2. All it's asking me to do is rearrange. So my base down here is 6. And remember, the exponent is always what the log is equal to. So 6 squared is equal to 36. And that's a true statement. When I write a log, if I were to get rid of this 2, if that were gone and I were to just say log base 6 of 36, the question I'm really asking is, what exponent do I need to turn this into this? Okay, I'm asking, what exponent do I need to turn a 6 into a 36? Let's see what else we got in here. Let's do number 3 also, just because I know you're going to be scared of it. Same process as before, even with the fractions and the negatives. I know it's scary, but here's our base. So we're going to go 14 to the power of negative 2 is equal to 1 over 196. And think about what you know about negative exponents. That's Those exponents are the ones that make things turn into fractions, so that's why that looks like that. Okay, we're saying 14 to the power of negative 2 would be 1 over 196. Okay, let's pick one from down here. This is going the other way. So this is giving it to you in this form and wanting you to write it like this. So for number 5, let's go number 6. For number 6, I would say log base, and it would be the base of the exponent, or I'm sorry, the base of the power. So log base 12 of 144. Because remember, you always want it equal to the exponent. Okay, equals 2. So when I say log base 12 of 144, again, what I'm really saying is what power turns a 12 into a 144? Answer to that is 2. That's all you're doing is rewriting these. You don't have to solve it. You don't have to do any math. You just have to rearrange the pieces. Let's look on the back. The back is the exact same thing, except it has letters in it. But you're still just following that pattern. You're still just writing. So these ones that are written as logs already, you're going to write them in exponential form. So you're going to write them as something to the power of something equals something. Down here, these ones are written as exponents, and you're going to rewrite them as logs. So you're going to say log base something of something equals something. Let's go down to one of these that we have to evaluate. Now, there is a way to solve these, like in your calculator. We're going to get to that eventually. These, though, are supposed to be sort of common sense, or at least guess and check. So make a note of that. That really in this section, we're talking common sense and guess and check. And to do that, let me pick one. Let's do number 25, because I think I opened the lesson with that same example. When I say log base 5 of 125, I want to know what is this equal to. So now I'm actually trying to find an answer. Well, the answer to a log is always an exponent. What I'm really looking for here is 5 to what power equals 125. Okay, I want to know what power is it that turns a 5 into a 125. Well, some of you know already. If you don't know, go in your calculator and take 5 and start raising it to a bunch of powers. 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, until you find one that works. You should find that it's 3. Okay, so the answer to this one, number 25, is 3. That's what all of these are asking you to do. So, like number 28 is asking you 2 to what power would give you 16. Okay, and then you have to figure out what power that is. A couple of things I noticed right away. Let's see. So something like number 24. Okay. 3 to what power gives you 1 over 243? The only way you turn a number into a fraction like that is with a negative exponent. So this one's going to be a negative answer of some kind. And then looking at number 27, I want to take a big number like 343 and raise it to a power to turn it into a 7. That's going to be like a fraction exponent. Okay, to make a big number smaller, you're going to use a fraction exponent. Okay, just to give you a hint there, but the rest of them should be pretty straightforward. Okay, I would like you to take about 20 minutes and finish off the rest of this sheet front and back. I know that sounds like a lot, but if it takes you more than 20 minutes, you're doing it wrong, or you're just not focusing. So take about 20 minutes. The substitute will come around and check and see who's got this work done. And then you've got another new lesson to tackle today. So please make sure that you are working diligently.